in typical.
This is Ford fashion.
Yeah, that's right. You know it. Okay. For the functions shown, we're on our review sheet, state the zeros and the multiplicity of each. Okay, so what are the zeros? What do we mean by zeros? Zeros are the x-intercepts. So we are simply going to figure out what our x-intercepts are. So what do you think? We got one at -4. We got one at -1. What do we do? And we got one at 3. Is that it? Now, what about the multiplicity? Well, what can you tell me about the 0 at -4? Look at the curve. What's it doing? Passing straight through. So it has multiplicity of 1. It's a single 0. Normally when it's 1, you don't write it down, but since it asks for multiplicities, I'm going to go ahead and write it down. But what about the one at -1? What's that doing? That's squiggling through, so that has multiplicity 3. And then what about the one at 3?
It bounces.
It's squared, it's bouncing, so it is squared. Beautiful. Use limits to describe the end behavior. So remember, that's the end behavior. Does this function have a name? Nope. Call it F. So we're going to have the limit as x approaches infinity, and the limit as x approaches -infinity. Right? End behavior. So tell me about positive infinity. What's happening that way? Negative infinity. And what about negative infinity? Same. Which means, by the way, that if I had an equation for this, what would be its degree? Even, right? Which makes sense because what's 1 plus 3 plus 2? 6. Yep. Not only that, but the leading coefficient would be negative because we've got down, down, and we should have up, up. Declan?
When we state the degree, how do we know that it's like 3 and not like 5?
We don't. So generally speaking, it's minimum. What's the minimum degree? Yep.
Alright.
Yep. Because you're right, this could be a 4. This is the only one I know that's a 1. But these could be something else.
Yep.
All right, I have a function here. This one gave some of you some trouble when it showed up on another quiz. Not determining if it was even or odd, but in actually proving that it's even or odd. Remember, the proof is this. If you are even, then k of -x equals k of x. That is the definition of an even function. So, if I find k of -x, what will that equal? If you put in a -x, what are you going to come out with? -x cubed minus 4x plus 2. Does that equal the original problem, k of x? No. So it's not even. There's your proof right there. It's not even. All right. Now, what does odd mean? Odd means that k of -x equals the opposite of k of x. Well, I already did k of -x. Is that the opposite? Is -x cubed minus 4x plus 2 the opposite of the original?
No.
No. So it's not odd. An even function has symmetry about y-axis. Yep, good. Given the indicated residual plot, state whether the model used was appropriate or not. So for number 4, the top one there, would you say that a given model is appropriate appropriate or not appropriate? Appropriate, because the residual plot is random. Okay, what do you think about this, the one to the right, I should have numbered those, the one to the right there? Not appropriate because the residual plot is predictable, right? It's predictable. All right, what do you think about the first one in the bottom left there? I think that one's appropriate. I don't think that those are necessarily predictable, but I don't think the last one is appropriate. Do you? You see a pattern there? Everybody okay with that? Next page. What type of model? Oh, take a second and work these out. What type of model is represented by the data? See if you can figure it out. Your choices are linear, quadratic, and exponential. You done? What'd you decide for A? Quadratic. And you base that decision on what?
Second differences.
Second differences were constant? Or the first differences were linear, going up by the same amount. So that's up to you, whichever one of those you want to use. What did you decide about number 2 or B? Linear, because the constant, or the first differences are constant, they're the same. And what did you decide about C? Exponential, because the differences are proportional. In fact, you can tell, these are easy Y's. We've had some hard ones before, but these are easy Y's because they're just all being multiplied by 4. Yeah. All right, 6, fill in the blank. Again, quadratic, linear, and exponential. What kind of model is best if the differences of the Y's over equal intervals of X are constant? Linear. That is the definition of linear, isn't it? What about the second one? The differences between the differences of the Y values is constant. That would be quadratic, because the differences of the differences is the second difference, so that would be quadratic. And then we want the proportions to match, so the last one is exponential. Okay. Number 7, we got a residual plot. What is the meaning of point A? We have no idea the context of the problem. All we have is this plot. How would you explain what was point A?
That x equals 3
Now, let's say that again, so where x is 3, the what?
The model.
The model did what? Overestimated? Because how do we find a residual? Actual minus predicted. And if that turns out to be negative, as it did, then that means the predicted was too big. So it overestimated by how much? What was that value? It's over there in the chart. 0.3, by about 0.3. So if these were weights, we would say that where x is 3, the model overestimated the weight by 0.3 pounds or something. All right, number 8, match the equations to the graphs. There's 5 graphs and 4 equations, so I don't know, we'll make do, we'll figure it out. So let me number my graphs, 1, 2, 3, 4, 5. Tell me which equation matches up. So we've got 1, 2, 3, 4, and 5. Those are our graphs. Number them. All right. So what do you think? One is C. Let me see. Do I agree with that? One is C. Y equals. Forget that for a minute. Y equals 2 to the x would look like this. When I multiply it by a negative, it's going to make it look like that. Is that what I've got? Yeah, I can look at graph 1. Yep, I agree. Well, good. Okay, so that's C's taken care of. Anybody see another one? 2 is B. 1/2 to the x minus 2. Now, 1/2 to the x is going to be the k. Would everyone agree? And then we're going to drop it down 2. And you said that was. Okay, that's not right, is it? Do I even have that picture up there? I don't think that's right. Do I have B on here? I don't think I even have it. The third one? No, the third one's going the wrong way. All right, so I guess B's not even there. Okay, what about C? Oh, C I already did. What about A? 2/3 to the negative x. What does it look like? 2/3 to the negative x. What does the negative x part do? Let's see, so it's actually, I'm actually graphing 3/2 to the x, which that would be equation 4, wouldn't it? Wouldn't equation 4, I mean, picture 4 would be equation A. And then what about the last one? The last one's going to be -5, 2/3 to the x. So 2/3 to the x looks like this. With the negative, it's going to flip it over and look like this. Do I have that one there? That's number 3. 3 is equation B. Let me double check. I don't think I have a picture of B on there. Because B would be the K.
I thought 2 was B. I just said 2 was because it has like an asymptote.
It does, but I think it's going the wrong direction. Because wouldn't equation B be decay?
Oh, you're right.
And
shoot.
picture 2 is a growth. Yeah, I think that's just a typical screw up on my part. All right, we muddle those waters enough. Everybody okay with those pictures? All right, sequence problem. Given the third term is 10, and the seventh term is 16. We want to find a formula for the nth term and the 13th term, given that it is arithmetic. Okay. So, I don't know, one strategy would be to say, okay, to get from the 3rd to the 7th, I'm gonna have to have 4 D's, 4 common differences, 4 additions. And I gotta cover a total ground of 6 units. So my common difference must be 3 halves, 1 1/2. To get my first term, which is handy if you're writing the formula here, not totally necessary, but handy, it's easy. I'm just gonna back up a couple of 1 1/2s, would you agree? So if I back up 3, I think I'll be at 7. So my first term is 7, my common difference is 3 halves. I'll clean that up and get 3 halves n plus 5 1/2. Oh, if I did that right. Yeah, I think that's right. And then the 13th term, I don't know, I'll just plug in 13. So 39 halves plus 11 halves. Did you get it? 25? All right, are we good there? Anybody have a question about any of that? There's some arithmetic in there. Good? Now, same thing, but now it's geometric. So the same given, only this time we're multiplying, so I need r to the 4th. I need to multiply 4 times by r, my ratio. 1, 2, 3, 4 times multiplied. And I need the total ground to be covered to be 16/10. Because I gotta multiply to get from here to here. This is a multiply. I multiply by 16/10 and that would get me here. But I have to do that in 4 steps. So what's my ratio going to be? The 4th root of 16/10 or 8/5. I don't have any idea what that is, but to work my way back to the first term, I would divide by that twice, working backwards. All right, so let's see what that is. Did you get your ratio to be about 1.12468?
Yeah.
And then you can divide by that. 1.12468 to be about 7.9057. I didn't hear any yes, is that okay?
How do you Mrs. Ford, how do you get your first term? Like on
I did it the same way I did over here. Here, I subtracted back twice.
Mhm.
Here, I have to divide back
Okay.
twice.
Sweet. You just do 10 divided by 1.12 and then do it again.
Yeah.
Okay.
I didn't round it off, but
Yeah,
yes,
yeah.
essentially that's what's happening. So I came up with this, and I carry a bunch of decimal places, because with exponentials, round off can cause damage. Anybody else get this number right here? Oh,
When you were dividing to get your first term, did you like make your answer like the 1.12468? Did you like make that a variable so you could just divide by it? Or,
you
like,
can. You mean store it as a variable, you mean?
Yeah. Or, like what?
You can. I just use, your calculator will just pull that in. If you use your answer button,
Oh.
so above the negative, see where it says answer?
Oh yeah.
It'll pull that in for you, but yes, you could store it as something and pull it up.
On the test or quiz, the first one on the arithmetic with the n-1, like, would you want us to simplify it to the
Yeah.
circle?
Yeah.
Alright.
Because you're always gonna be able to combine this. Yeah,
Just circles.
okay, all right. Oh, wait, and then what was I supposed to find the 13th term? So I don't know what we got there.
You guys like
I got 32.3808. How does that sound for your 13th term?
I got
Okay.
my
Using limits, express the end behavior of this exponential. Let's draw a little picture of it. Let's take care of that. What's that do?
1/4.
1/4, which tells me that I'm going to have decay. That's positive, so it's not changing anything in terms of the general shape. So I got this. So using limits to describe the end behavior, to the left, it's positive infinity, and to the right, it's 0 from the top. All right. 11. This kind of problem gave some of you some trouble on your homework. Tomorrow we'll get back all of our homeworks and go over the questions there. Some of you already got some of the fact. But the directions say it needs to be the form y equals ab to the x. In other words, no horizontal translation. We want a vertical dilation instead. So we recognize, what does this mean algebraically? 4 to the x times 4 to the negative second? Because wouldn't we add these exponents? Can we get that? What's 4 to the negative second? 1/16 times 4 to the x. So your A is 1/16 and your B is just 4 to the x.
Mrs. Ford?
Yep.
Would you count it wrong if we just split the 4x over 16?
No, that's fine. It does say A times B to the x, so it's probably better to write a distinct A out there in front.
Yeah.
But it's the same thing. All right. B. What's happening here? Well, we've already got a vertical dilation there, but 2 times 6 to the x times 6 to the first. Does that look okay to everybody? So we're gonna end up then with 12 times 6 to the x. This does not have a horizontal translation, but I do have to fix the exponent, because I need my exponent to be x. So remember, this would be the same as this, wouldn't it? And what's 16 to the 1/2? 4. So your function is 3 times 4 to the x. Any question about that? That in the homework was not good for some of you. You all right with that? Which of the following functions is equivalent to y equals 3 times 4 to the 2x? What do you think? You got any thoughts on that? B, because this is the same as 3 times 4 squared to the x. So B is the correct answer. Good work, good work. Which of the following statements about the graph of f is correct? A, it is increasing at an increasing rate. How do I know that? Concave up. It's concave up. Perfect. Beautiful. Which statement is true in number 14? Now wait, think about what that looks like. That's this turned upside down. So what about that? It's definitely decreasing, and it's decreasing at a decreasing rate. Concave down.
Decreasing because it's getting steeper down.
Okay, wait. How do we determine the rate of change? The change in the rate of change. We look at the concavity.
I'm
Right?
still confused how it wouldn't be at an increasing rate because it's getting steeper. It's going down faster.
The rate's getting more negative.
So,
Yeah, but it's speeding up how fast
okay,
it's
but
going.
wait. So, like Declan said, or whoever that was over here said, the slopes are getting more negative. Would you agree with that?
Yeah, so it's
Okay,
decreasing.
wait. So we're going from -2 to -4 to -6 or something. What, think of your number line. What are those numbers doing? Are those numbers getting bigger or smaller? So you're getting this confused with like velocity. I guess. I don't know what you're getting confused with, but it's getting more negative, which means it's decreasing. Absolute value wise, they are increasing. You are right. If you take the absolute value of all those, but we're not doing that. We're looking at the raw numbers. They are decreasing. They're getting smaller. They're getting more negative, bigger negative. Does that make sense at all? I know intuitively, I get what you're saying. I get what you're saying. But from a pure numerical standpoint, they're they're getting bigger negatives.
Is that what you want me to say?
All right, we've got an arithmetic sequence, find b plus c. All right, so what's your thought here?
Oh. Where's Ford? I got it.
You got it?
Can't we just do like, since it's arithmetic, like the difference of like 59 minus c and like set it equal to a different difference? Because they're the same difference, right?
Well, but be careful, these are not evenly spaced.
Oh, shoot.
So if, you would be exactly right, if this were a 9, then yes, that difference would match this difference exactly,
Okay.
okay? There might be something you could do along those lines, Cole.
Wait, couldn't we just multiply c minus 27 by 7 to make it equal to the other one? To make it equal to 59 minus c?
I don't know what's going on.
Okay, so
I don't like it.
what Cole is saying here is that this is like the 7th term and the 8th term, so these are 2 consecutive terms. So he's saying this is actually the common difference of the problem. Would you agree with that? And he said, okay, then to get from here to here, I have to add 7 of those. So if I were to take 7 of these and add it to the 27, well, actually, I would have to add it to C. I should get 59? Now wait, before you say anything, does his logic make sense to you? Now that may or may not be the way you are thinking about it, but is that logical?
This logic does not make sense to me. I'm confused.
Okay,
Why is
so-
minus 27 the common difference?
Because I have to get from here to here.
There's only one term.
That,
The
I'm
others
going
have
from the
multiple
7th term
terms.
to the 8th term. So, I mean, if you, so let's say you have the 7th and the 8th, you knew this was 5 and this was 10. What would the common difference be? How am I getting from the 7th term to the 8th term?
Either
I'm adding
multiply
5.
by 2 or add 5.
Okay, let me make this 6. Okay.
Add
So
4.
how am I getting from here to here?
Add 4.
Add 4. Where did 4 come from? 10 minus 6.
I got it.
So it's just a letter, but it's doing the same thing. All right, so let's go ahead and solve his equation. So if we start right here and add 7 differences, we should end up at 59. So what does that say? C plus 7c minus, oh Lord. What is that? 89. So 8 C's is, again, you might not do it this way. I'm not sure I do it this way, but it's okay. I think it's okay. So he got 31, not as the common difference, but as the C value. So then he can see that his common difference is 4.
Yeah.
And then you can do the same thing working backwards from 19.
That was a 6.
Wait, do I have math mistake?
Wait, that's
No, I think that's 31.
why would you just why would you
And
just
then
do
I'm gonna
5%?
back up, to get from here to here, I have to back up 4, is this 3?
I'm not got.
And so your job was to find B plus C,
Someone clip that.
so the answer would be 34. Now, let's hear some other ideas. Cool, that logic is fine. That logic is fine. Alex?
I found the average rate of change of A of 7 and A of 5.
These two right here?
Yeah. And
So he said 27 minus 19 over 7 minus 5, and that was, oh, looky there. Exactly what Cole said, the difference was 4, okay? And then he just kind of did what he did, both ways. Perfect. that'll work. Why does that work? Because it's arithmetic, and what do we know about arithmetic? They are linear, and what do we know about linear? The slopes are the same. He found the slope. And worked from there. Good job, all of you. Okay. All right, have you figured out 16 yet? What is going on there? All right, I'm writing an exponential. I know f of 3 is 24. And I know f of x plus 1 over f of x is 2. Thought? Yeah, Olivia?
I plugged in the 3. Well, I feel like I kind of. I plugged in the 3 for x
Mm-hmm.
in the f of x plus 1 equation.
So 24, I presume you put this in here then. So
Yeah.
24 equals a times b cubed.
No. Well, yeah, but I did like f of 4 over 24.
Oh, you did down here. Oh, I'm sorry.
Right.
Okay, okay. So you said f of 4 over f of 3 is 2?
Yeah.
Okay,
And then I found f of 4, and then the rate of change is 2.
okay.
Anyway.
So she said, I know f of 3, so f of 4 over 24 is 2. So f of 4 must be 48?
Yeah.
So she said, I know the third term was 24, and I just figured out the fourth term, oops, was 48. So therefore I know my ratio, or my b, is 2.
Yeah. And then you plug,
So that meant this was 2.
yeah, and then I solved that out to find
So then a, let's see, that's 8. A has to be 3?
Yeah.
So you said your function is 3 times 2 to the x?
Yeah.
What do you think about that? Yeah, that is absolutely beautiful, Olivia, perfect. But it's a lot. You did a lot there that was actually told, you were given it right here. Because what do we know about f of x plus 1 and f of x? They are consecutive terms. So whatever my sequence looks like, if this is f of x, this is f of x plus 1. Does that make sense to you? And if their ratio is 2, then isn't that my ratio? Isn't that what I'm multiplying by? So this right here is the common ratio, because it's the ratio of consecutive terms. 2 terms back to back. So you actually kind of proved all that, Olivia, by going through all this, but actually write that, there's B, right there. But anyhow, yep, good job, good job. All right, 17, here we go. Let's see if we can get this done. Which statement is true? D. Decreasing in concave up. I always have to sketch these things. This guy, well, actually, maybe I don't sketch this one. This one is decay. And he hasn't been flipped or anything. So decay is decreasing and concave up. Yep. Yep.
I feel like
All right, which is equivalent to this one? 100 times 9 to the x. C? Because 9 is 3 squared. Beautiful. The distance in meters that a toy can travel after being pulled backwards is given by this equation. C is in centimeters. function to give the distance pulled back in millimeters. So I gotta adjust this somehow. What do I know about millimeters? There's
100 times.
10 of them in a centimeter. So if I divided this by 10, and now this is millimeters. 10 millimeters would be the same as 1 centimeter. So yep, that's exactly right. Yep. That problem is exactly like, remember we had one where we had to go from months to days or something like that. We had to change our exponent.
Oh, yeah. No, it's months to years.
Months to years, whatever it was, yeah. We had to change our exponent.
Wouldn't you multiply it by 10 to get from centimeters to millimeters?
Okay, now you gotta be careful. You have to be careful
Wait,
because
that's a good point.
it's kind of counterintuitive. This was 3C, right? When this was centimeters, okay? So if you do 1 centimeter, then your distance would be this, right? If I had 1 centimeter?
Yeah.
Okay, now look up here, this one. Now I'm going to do 10 millimeters because that is the same as 1 centimeter, right?
Yep.
So if I do 10 millimeters, I should get exactly the same answer. So if I put 10 in here, don't I get exactly the same answer? If I put 10 in there?
Yeah.
Yeah, so it's kind of counterintuitive, but the idea is they have to be the same.
So
So I gotta modify the exponent to make my output match. All right, 20. Okay, so the first thing we have to do in number 20 I'm gonna need to find, I'm gonna have to find the regression. So the first thing I'm gonna do is find the regression here. So stat edit. I should not be the only one typing. Probably not gonna get this done, but we can at least get a regression done. Bless you. Yeah, I typed in the wrong numbers first, so I don't know, I think this is right. I got 5.454 x squared minus 3.852x plus 4.82. Anybody else get that, or did I type in the wrong numbers? Did you get that?
Yeah.
Perfect. All right, so then it says, find the residual when T is 2? Well, one option I have is just to go over to my residual column and pull it out of there. So if I do that, I got the residual at 2 to be 1.8006. What are my other options? What else could I do? Plug 2 into my equation, and I could do use my y variable and then subtract 20.73 minus that. Find the year in which the number of iPhones is 200 million. How are we gonna do that? I'm graphing. Anybody else graphing? So if you're having trouble with your window, think about the problem. Your minimum values have to be 0 because you can't have negative years since 2007, and you can't have negative iPhones. So I did the intersection, and I got 6.346, which means when? Years since 2007, so sometime in 2014. What is the exponential model for this situation? What are you gonna do? Yeah, what did we find already? What we found already is a quadratic regression. So now we just go back, the data's already in, we just go back to stat calc and do an exponential regression. I got 2.877 times 2.266 to the x. Find I of 6 with this model. Now remember, with our quadratic model, we found out that after about 6 years, we would be at 200 million. What happens here with the exponential model? Oh shoot, I didn't store that in. Anybody have it? I didn't store it, so I'm gonna type it back in again.
I got 389.796.
You got 389? Wow. So you're not, so. Why equals? Remember, that's million. That's million. You have any comment about that? Any thoughts about that? Yes?
Is the I not meaning?
It's the function. It's the function. We need those functions, I guess. Okay, which one do you think is a better model for the reality of the problem? Now, wait a second. This is 400 million, almost 400 million. And under the quadratic model, in the same period, we did 200 million. In 6 years, 200 million. In 6 years, 400 million. That was 6 years, okay? Just 6 years. You see any problems with either one of those models? The exponential is going to outlive its value because it won't be long and there won't even be that many people in the world to, alone having an iPhone, right? Do you see what I'm saying, you guys? Exponential is unrealistic. It might be okay in the short term, but it's unrealistic in the long term because it's going to generate numbers that are just far too big, far too big. Okay, we're gonna stop there. We got, what do you have, a couple more problems to go? Alright, we didn't do the residual plots, we'll do that next time. Oh no, we got a back. Alright, we'll finish that next time.
When will our quiz be?
It'll be Tuesday. Tuesday. We have one more review day. Stop, we're going to lunch.